Diabetes Connections is brought to you by One Touch. Every touch is a step forward. By Dexcom. Take control of your diabetes and live life to the fullest with Dexcom. By Tandem Diabetes Care, makers of the t:slim X2 insulin pump. And by Real Good Foods, real food you feel good about eating.
This is Diabetes Connections with Stacey Sims.
Welcome to a bonus episode of Diabetes Connections. I'm your host, Stacey Sims, and this is the full interview with Dr. Michael Haller from TrialNet. Excerpts from this interview ran in the episode immediately preceding this one, but as we're doing at the end of every month this year, we're making the entire interview available on its own. This is all about prevention. Preventing type 1 diabetes, when I hear about it, it still sounds kind of like a dream, right? I mean, is it really going to happen? What's the research saying? Is it possible? No autoimmune disease has been cured or prevented for any length of time before. So how are they going to do this? But this year, we got some really interesting and optimistic research. So my guest here is the chief of pediatric endocrinology at the University of Florida. He is the principal investigator or co-investigator of some incredibly promising studies going on right now to try to prevent type 1 diabetes. Now, we have talked about TrialNet here on the show before. We've done programs all about TrialNet. I will let Dr. Haller explain more of what it is in just a moment, how it all works. But in June of this year, TrialNet made headlines by announcing the first real delay in the onset of type 1 diabetes. They were able to delay the onset by 2 years. Dr. Haller explains what that means, how they do these studies, why he's excited about his work, but still really frustrated. And we talk about how we can help. Dr. Haller, thanks so much for joining me. Exciting times. I'm really excited to talk to you today.
My pleasure to be here.
Okay, before we get into the prevention studies that came out and other things that are going on, let's really kind of dial back and start at the beginning. Can you tell me a little bit about what TrialNet is, what you're trying to do?
Sure. So TrialNet is an NIH-funded consortium of the top type 1 diabetes centers across the U.S. and Canada and even Europe and Australia. And our goal is to try and develop therapies to ultimately prevent and reverse diabetes. And to achieve that goal, we have to identify patients who are either newly diagnosed with type 1, so we can encourage them to participate in research studies, trying new drugs to see if we can protect their remaining beta cells, extend their honeymoon phase, and hopefully eventually get to reversal of their disease. And then the bigger chunk of what TrialNet does is actually tries to identify folks who are at high risk for developing type 1 diabetes by screening family members of people who are already affected with type 1 to see if they have markers of autoimmunity, and then either follow them to see if they progress to being higher risk or put them in prevention trials aimed at trying to delay their disease. And so that's really the main emphasis of TrialNet. It's a huge operation, as you can imagine. Trying to identify people who are at risk for type 1 is not easy because people don't walk around with a name tag on that says, "Hi, my name is Mike. I'm at risk for type 1." We have to draw their blood and identify markers in their blood, and we have to talk people through why they would want to do that. So it's an exciting time for all those efforts, but it's certainly a big challenge.
Yeah, well, and I'm going to skip around here a little bit, so forgive me if as you listen, this sounds out of order, but I have to jump ahead because the news came really recently that we had the first study to show that any drug can delay type 1 diabetes, the diagnosis. Can you talk to us about this? And I'll guess I'll try to say it, but what is the name of this study? Teplizumab?
I'll do it for you.
Sorry.
It's called teplizumab. It's a mouthful. Teplizumab is a monoclonal antibody designed to track the parts of the immune system to knock out or kill cells that have a marker on them called CD3. And CD3 is sort of like a name tag, to use that analogy again, for these kinds of cells that are going out and attacking the pancreas. Now, unfortunately, it's not so specific that it only attacks those cells that might be targeted at the pancreas. There's some collateral damage that it gets rid of other cells that are part of the immune system. But that's the big challenge in type 1, is trying to find drugs that can get rid of the cells that we want to get rid of and not the ones we want to keep. But the results of this study are really truly exciting and paradigm shifting for the field. As you mentioned, this is the first time in the history of type 1 that we've been able to show that anything can really durably delay or prevent the disease from progressing. So what that study did was take patients, like I mentioned, who are high risk for developing type 1, so family members of somebody who has type 1, who had markers in their bloodstream that told us they were going to progress to clinical disease where they'd need to take insulin in the next several years. And they were treated with this drug, this immunomodulatory drug, teplizumab. And what the data have now shown, and the paper was recently published in the New England Journal of Medicine, was that in fact the drug did delay onset of type 1, which means there was actual prevention in some of the patients on average for at least 2 years. And so while it's certainly not a home run, we can't guarantee that we're preventing the disease forever in the patients who received the active drug versus who received the placebo agent. It's a huge win for the field of type 1. It establishes the proof of concept that we really can effectively change the natural history of the disease. And I hope that it accelerates our efforts to do more and more studies with other drugs like teplizumab and adding additional agents to try to get an even better effect for our patients so that we can ultimately say, hey, it makes sense to screen everybody for their risk for type 1 sort of as a public health initiative and treat them with these drugs to prevent them from getting the disease.
Wow. Yeah, something I've always wondered, and I don't know if you can answer this, why is it so difficult to prevent or treat autoimmune conditions? It's not just type 1, right? I mean, nobody's cured or really prevented an autoimmune disease, have they?
Yeah, it is a challenging beast. The immune system is really smart even when it's confused about what it's supposed to do. And so once the immune system has decided it wants to attack self-tissues, which is what we mean by autoimmune disease, and in type 1 we just are specifically looking at the immune system attacking beta cells, it figures out all kinds of different pathways to get to that end and cleverly changes the way it does it. And so it's in fact probably not surprising that it's been so challenging just given the way autoimmune diseases in general come about and specifically how type 1 happens. And in the type 1 space, we're further challenged by the fact, and it's a good challenge in the sense that we've gotten better at caring for diabetes. So people reasonably would say, I don't want to take a therapy that's a risky agent or drug to prevent or reverse the disease because I can potentially take care of diabetes with insulin and pumps and continuous glucose monitors. Now, I don't live with diabetes personally, but I have a personal connection to it. My grandfather had type 1, and I take care of patients every day. And while I understand that argument, the majority of my patients I talk to say, and I fully understand that living with type 1 is incredibly challenging and hard, and more patients than not are actually willing to accept a little bit of risk for the potential benefit of delaying the disease. And certainly a 2-year delay for most families who've now lived through this would be tremendous. And most folks who have gone through that would say, man, if I could have just gotten my kid from 6 to 8 or 8 to 10 or 10 to 12 or any amount of time, some even say a day would be worth it, that'd be totally fine.
Personally, my son was diagnosed right before he turned 2. And I got to tell you, from almost 2 to almost 4, I'd take that in a heartbeat because he could not even say diabetes when he was diagnosed.
Yeah.
I mean, the communication was not there. I mean, it's unbelievable at that tiny little age to get them to tell you what's going on. But let me ask you about the people in the study. Do you mind sharing a little bit about, how does it work? And my hat is way off to anybody who takes part in any kind of clinical trial, whether it's technology or, these, anything with drugs or medications. These are pioneers and people who are sacrificing, even if they may say otherwise. They're taking time, they're driving, they are taking risks. So my hat is way off. But can you tell us a little bit about what kind of goes on during something like this?
Sure, and thank you for bringing that up. Yeah, the patients who participate in these studies are absolutely the diabetes heroes. Sadly, not enough patients are able to participate in studies just because of the time commitments and the logistics and maybe being risk averse, like you mentioned. So if you know somebody who participated in a study, please give them a hug and a high five and a hearty thank you, because without those folks, we can't find these things that might work and move the field forward. Did you want me to explain how the drug works or how participating in the study goes, or both?
I guess, well, let's start with the study. Like I'm a mom, I've got a 6-year-old or whatever the age of the person is in the study. Yeah. So, what do we do? I don't know how much detail you can share or what might be interesting, but I've never participated in something like this. So I show up at TrialNet. What do I do?
Right. So TrialNet starts with a screening study. So we just draw some blood from somebody who's got a first-degree relative or a second-degree relative with type 1 diabetes. And if their markers in their blood show they have the antibodies that we associate with risk for type 1, then we ask them to come back for additional testing. And the frequency of that testing is dependent on what we learn about their risk from the next set of tests. And so for patients who are particularly high risk, which is the kind of patient who was enrolled in the teplizumab study, if they were old enough to be in the study and they had the right risk markers, which included completing an oral glucose tolerance test that was already abnormal but not quite at the diabetes diagnostic level. So these were patients who were really, unfortunately, high risk, really on the verge of getting diabetes within the next few years. They were offered the opportunity to participate in this trial. And when you mentioned that it's a big commitment, teplizumab is not an easy drug to receive. It required a 14-day infusion of the drug as an IV. So every single day for 2 weeks, patients had to come in and get poked and get an infusion, which was technically a half-hour infusion. But by the time you come and get your IV placed and get drug and follow up, we're talking about several hours every day for 2 weeks. So a huge commitment. But nevertheless, if I told you that that 2-week commitment was going to buy you a 2-year window or potentially longer of diabetes-free time, I don't know many patients or families that wouldn't say, sign me up. And so I think it is a paradigm-shifting thing. We hadn't had something that done this before, and now that we do, I hope that it will encourage more and more families to participate in the research process, to sign up for screening, to hopefully find other therapies like teplizumab, to find out how we can improve on the teplizumab findings, and so that we can ultimately tell patients one day that, we're screening your kid not just for research, but because we know we can do something about it.
What's next for teplizumab? Is this study kind of done? Do you now start something new to see if you can prevent it longer? What happens next?
Yeah, a little bit of both. So we obviously met the study's primary endpoint and published those data. But now there are lots of questions to ask and answer, which is how long does the benefit last in those who got treated? And what happens if we retreat some of those patients who got drug, appear to be responders, and still haven't developed type 1? Can we extend the benefit even longer if we give them another course of the drug? And so TrialNet is actively looking at those options right now. I think one of the challenges for teplizumab specifically is it's not an FDA-approved drug for anything at this point. It's still been, even though it has a long history of being developed for this purpose and being tested in the type 1 space multiple times, in new onsets and now in this prevention space, it's still never been licensed. So despite the excitement about it, you can't just go out and get this today from your endocrinologist or anybody else. The only way to get it would be through a study. So the company that owns it is certainly very actively trying to do new and additional studies, both in newly diagnosed patients. In fact, they've just opened up a study that's not part of TrialNet, but it's by the company. And then TrialNet is going to be doing some version of either a retreatment study or treatment with teplizumab plus other agents is likely to come down the road, because we all still believe, given to your early question about the complexity of autoimmunity, that we're going to have to do more than just a single drug to kind of get us over the end zone. We're probably going to require combination therapies or what we call induction and maintenance therapy. So first treating with teplizumab and then some other drug to keep the effect going.
Another recently completed study, is my understanding, is ATG, GCSF. Can you talk us through a little bit of what that one is?
Sure. So the study of anti-thymocyte globulin, or ATG, and GCSF, which stands for granulocyte colony stimulating factor. I apologize, it's a lot of letters and names. Has been a labor of love and a passion of mine personally for the last decade or so. And the work that came out of that really is a beautiful example of the importance of translational science that came out of my institution at the University of Florida. So the story is really interesting. There was a transplant immunologist who was using fairly aggressive, what's called non-myeloablative transplant approaches for people with really severe bad autoimmune diseases like end-stage rheumatoid arthritis and multiple sclerosis. And he was having really impressive outcomes, but his approach was really quite aggressive. It would be akin to almost doing chemotherapeutic treatment for these patients. And so he started to talk about the potential of using that approach in type 1 diabetes. And honestly, the U.S. type 1 community just wasn't willing to think about that because the risk level was so much higher and we hadn't really had any successes yet. So we ultimately took that approach to a group in Brazil and did new onset patients with this approach there. And to date, it's still probably the most potent way to provide a short-term reversal of type 1 diabetes that we've seen in newly diagnosed patients. And so our group was really interested in that, but felt we really have to dissect this, take it apart, deconstruct it, and try to put it back together in a way that would make sense for treating kids in a U.S. audience because the risk there was just too high. And so we went from the bedside essentially back to the bench, and we started doing animal studies in a mouse model of type 1 and found that two of the drugs that they used in this sort of very complicated approach really gave us the most bang for our buck. And those two drugs ended up being anti-thymocyte globulin, ATG, and GCSF. And so once we had demonstrated that repeatedly in the animals, we decided we would do a pilot study in humans. And the first thing we did was actually study this in folks who had what we call established type 1 diabetes, people who had diabetes for at least 4 months, but as long as 2 years, because that population often largely has been ignored in the type 1 intervention space, even though we now know that many of those patients have lots of beta cell function still around. And what we were able to show was that the combination provided for almost a 40% preservation of their ability to make beta cells, to make insulin, out to 2 years after a 2-day treatment of anti-thymocyte globulin and a 12-week course of the GCSF. And so that was really exciting, but we wanted to then continue to move it sort of earlier in the disease process to new onsets and ultimately into the prevention space. So at that point, we convinced TrialNet and the NIH to fund a large confirmatory study similar to the teplizumab study we just talked about, but in new onsets to see if the low dose of ATG with or without the GCSF could provide protection for beta cell function and improve A1C. And we've now published 1 year and more recently 2-year data. And in fact, we did show that. So the most interesting finding was perhaps that the low dose of ATG by itself was able to provide for the most robust preservation of beta cell function and reduction of hemoglobin A1C in newly diagnosed patients. And so why I'm really excited about this approach is sort of related to what we just talked about before with teplizumab, in that anti-thymocyte globulin has been around for 25 years. It's a commonly used medicine in hospitals every day. It's primarily used for pretreatment of folks getting kidney transplants. But in that indication, they use it at a 10 times higher dose. So we're using it as a very minimal dose of this drug, and we still need to do more studies to confirm our observations. But the pathway to taking it into the clinical care of patients is perhaps a little bit more direct because it's been around and it already has a label. Now, of course, we'd have to do additional studies to get a label for it in the type 1 space, and that's being considered right now. But I'm excited about the opportunity to continue to study ATG. I think it's very similar to teplizumab in many ways. It has some advantages in that it only requires a 2-day infusion instead of a 14-day one. And so the next step is for TrialNet to start a prevention study, and that study is being planned as we speak. That would be very similar to the teplizumab study that we talked about. So taking high-risk patients, giving them a low dose of ATG, and following them to see if, in fact, that can prevent them from progressing to clinical diabetes where they need insulin.
So exciting. And you mentioned people with type 1 who are not newly diagnosed. Let's just talk about that for a moment, because I agree. I think there's a feeling that, well, these prevention studies are fabulous, and, one day we'll make sure that, no one develops type 1. But what about the people who do have it? Were you surprised? Or I guess I should ask you, put that in perspective for us, that discovery that they're still producing beta cells, that something can still be done here.
Yeah. A lot of people don't realize that. I think one of the best ways to think about it was an analogy that previous director of the JDRF made, which was if you think about an hour of the clock as being the amount of time somebody lives with type 1 diabetes, the new onset phase, which is the first 100 days where we've normally done these studies, is like less than a minute. And so we ignore the whole rest of the population who live with type 1, many of whom fund our research through being donors or advocates. We sort of leave them out of the opportunity to participate. So one, that's wrong morally, and two, it's wrong because we now have better science that demonstrates that people with type 1, especially those who were diagnosed a little older, unfortunately not kids like your son who were diagnosed so young, but people who are diagnosed as teens or even young adults often have functional beta cell mass for years. even 5 to 10 years is not uncommon. And that's quite variable, but we can measure that and know. And those patients are potentially a huge population who might benefit from some of these immunotherapies that we're talking about. So I think you're starting to see the pharmaceutical companies and the scientists who work with these drugs design trials to sort of re-enfranchise that population that's long been left out. So we felt that it was a very exciting and important finding from our study, our first study of ATG and GCSF, and now we are seeing other studies like it coming along.
All right, so let's just go backwards for a moment and talk about people diagnosed very young, like my son who was diagnosed at 23 months. I hate to hear something like that, but I have to ask, can you elaborate on what you meant by that, and what is the age of, I know it's not, nature has no real cutoffs, but, what ages are you talking about there?
Yeah, so unfortunately, kids who are diagnosed under 4 to 5 years of age tend to have a more rapid and severe disease in that their beta cell mass is less when they're diagnosed, and they just may retain less over a shorter period of time. And it's a little bit obvious, somebody who made it to 30 or 40 or 50 years of age before they developed type 1 obviously had a slower progression of disease. So in some sense, it's not too surprising that their progression after the day they need insulin is going to be slower than in somebody who unfortunately develops type 1 at 23 months. But as you can imagine, it's incredibly variable. It's one of the challenges of type 1. There's so many flavors of type 1s, and every individual patient is different. Having done this now for 20 years, I still, every time I walk into a patient's room, their diabetes is different than the patient I saw before, and it'll be different than the patient I see next. And that's probably true for some of the biology of what's going on with the immune attack. And so it's probably not a one-size-fits-all, or won't be a one-size-fits-all approach. And we have to get better at personalized medicine. So, what may work as a therapy to prevent diabetes in a 10 or 15-year-old or even a 30 or 40-year-old is going to be different ultimately than what will likely work for somebody who's, a year or two old and really high risk.
It's really interesting. As a mom, I'm disappointed. I don't want to hear things like that. But for the purpose of the interview here and the information, it's really interesting. And it kind of explains Benny, my son, had basically no honeymoon. Once he was diagnosed, and we were very fortunate, he wasn't in DKA. It was not an emergency situation that day. But boom, that was it. Looking back, we never had a honeymoon period. And I wonder if that's why.
Yeah, that's pretty common experience, unfortunately, for kids diagnosed that young. They just trash their beta cell mass so quickly that they effectively don't get a honeymoon. Yeah.
I shouldn't laugh, but that's a great way to put it. My son will be thrilled to know that he totally leveled it. He did, in one fell swoop.
He killed it. He knocked it out of the park. Not the game you want to win, unfortunately, but you mentioned something else though that's a really key factor, which is that he fortunately didn't develop DKA, but still, even in the U.S., 30 to 40% of new onsets come in DKA, and sadly that number continues to go up, not down. That's another really critical reason to do screening programs. While we can't yet justify general global screening for the purposes of preventing DKA, people who have a family history of type 1 certainly should get screened in TrialNet and be followed, because we know very good data that folks who are followed in these studies have a marked reduction in the likelihood of DKA for a subsequent family member who unfortunately might be developing type 1. And so while economically it doesn't make sense, obviously no parent who's gone through this would say that they wouldn't do something to prevent DKA in another child who might have to deal with it. And we're talking about a reduction from 30 to 40%, which we're seeing in the general community, down to 5% or less. So that's a huge secondary benefit of participating in these trials.
One thing that has come up recently, though, unfortunately, and as you say, you want to do more screening, but TrialNet seems to have had the funding cut back. Can you talk a little bit about the changes that have come? Because I did get, when I told people we were going to be talking about prevention and I was speaking to TrialNet, I heard from a few people who said, ask them how long the changes are going to go on. So let's explain what has changed.
No, I appreciate you asking that question. And for all your listeners, we appreciate your ongoing advocacy. Keep speaking up, being loud about the value you find in these programs. Talk to, your congressmen and senators. Ultimately, that's where the money comes from. TrialNet is funded by the National Institutes of Health, and we get a bit of a special allocation of money called the Special Diabetes Project, SDP monies, that fortunately looks like it's going to move forward with some newer funding. But yes, we did recently face some budgetary cuts because of decisions that had to be made at the NIH level. And because of that, we had to strategically talk about how much screening we could do to still identify the highest risk patients that we need to put in these prevention trials. And part of that calculus resulted in us having to cut back on the frequency with which we had previously been doing repeat screenings. But I completely agree with all the upset families out there. Part of the huge value of being part of our TrialNet family was being able to come back in for rescreening every year, and either knowing that your kid wasn't at increased risk this year, or finding out that unfortunately they were, but knowing that therefore that meant you would get closer follow-up and potentially be in a prevention trial. So I remain hopeful that decision will be overturned, to be short-lived, but at the end of the day, it's a purely economic one, and so. If any of your listeners have influence, or and everybody can, don't be shy about giving that feedback to either your TrialNet center if you're already in TrialNet, or talking to your legislators about why you think this is important.
We have international listeners as well, because TrialNet's not just in the U.S. Are these funding issues in like the UK as well?
Thanks for bringing that up, too. So TrialNet is mostly funded by the NIH, but we also get some funding in kind from the JDRF. And the JDRF funding has largely been used in the past to help us maintain the international centers.
Oh.
And so, they, as a group, given that we use the funding all the same, are affected in the same way as it relates to this current screening change, because we can't have a different program in different countries. But again, hopefully as funds will come back to the network, we will be having the ability to increase our screening programs. And I should say, some of the screening things need to be changed anyway, because the network is evolving and we're learning more and we have better, more precise ways of doing things. But some of the changes that were made were certainly a little bit more draconian than we had hoped.
Let's talk, if we could, about some other prevention theories. As you can imagine, with the podcast, I get a lot of interesting guest pitches and emails. And when I'm very careful, I have a no snake oil policy, and we try to do a lot of research before we let things through. But one of the things that comes up time and time again are stories about people who are diagnosed with type 1 diabetes, but prevent the onset or extend the honeymoon by diet. Is that possible? I don't know if you can even answer that.
So the short answer is it doesn't appear that that's possible. We don't have any evidence that supports that assertion. The longer answer is certainly if you restrict carbohydrates, which obviously that was the way we treated diabetes before we had insulin. You essentially went on a starvation diet, and that will no doubt reduce the severity of the hyperglycemia, but it doesn't ultimately change the beta cell destructive process. And unfortunately, before insulin was discovered, this was a uniformly fatal diagnosis. So there are a lot of people who are very interested and excited by using diet as part of the therapy for type 1, and I absolutely agree that it is an important part of what we do. Obviously, we all eat every day, and what we eat has a huge effect on glycemic load. But diet in and of itself is unlikely to be able to change the immunology and the natural history of the beta cell loss. And there really just isn't any data to support that of yet.
Anything else with prevention? I mean, verapamil is not a prevention drug, right? It's not with those trials, or is it?
It hasn't gone into prevention trials yet, but sure, there's tons of things on the list that we'd like to continue to try out. And honestly, the main limitation to do all those things is an inadequate number of people identified and willing to participate in the studies. TrialNet screens 20 to 25,000 people a year, but even if you're screening first-degree relatives, only 1 in 20 are going to have antibodies. And so, as opposed to 1 in 300 in the general population who are at risk for type 1. So it takes a lot of work to identify a high-risk patient, and then they may not want to participate in the study given the particular agent's risk profile or the logistics or any number of reasons. So again, we really need people to participate in screening because we have lots of drugs that we'd like to try. Verapamil is a very interesting drug that is an old blood pressure medication, and a recent publication demonstrated it may have the capacity to preserve beta cell function as well in new onsets. A relatively small trial in adults, so it needs to be repeated in children and adults. And then if those results are confirmed, it would absolutely make a lot of sense to use in prevention or combine with another agent. So again, we talked about maybe teplizumab plus other drugs or ATG plus other drugs. Verapamil would certainly be on the list. But I should mention that TrialNet is already planning additional prevention studies as well. So we have an open trial that's a mechanistic-based study, so it's really not designed to answer the question of whether or not this particular drug can prevent the disease, but it's designed to give us some scientific answers to questions that, if they look good, would lead to a larger trial. And that's using actually an old anti-malarial drug called hydroxychloroquine. And then there's another drug that's being evaluated for a trial as well. That's a really interesting story. It's called methyldopa. Methyldopa is a really old blood pressure medication. And through some really beautiful science, that drug was found to bind to a particular area that really is critical in the way our immune system sees insulin and might develop an immune response to it. So this was sort of a backwards way of discovering an old drug in a new way by screening entire libraries of agents to try to find things that fit into particular areas of a part of the immune system. And so that study is also being planned. So we have a lot of things in the pipeline. There's a whole number of other autoimmune drugs that are used for treating things like rheumatoid arthritis and psoriasis, and the list goes on, that we'd love to repurpose to see if they might work well in type 1. But to do those things, we need patients, families willing to participate, and of course, we need funding.
You mentioned that your grandfather had type 1 diabetes. What do you remember about that? Would you mind sharing his story a bit?
No, sure. So I'm not terribly old. I guess it's all relative. I'm in my 40s, but I remember even as a young kid when we essentially had 2 insulins, and that's what Grandpa took. And I remember very vividly when the first blood glucose meters came out, and I have sort of some memories of when he was still using CliniTest tabs for any of your old timers out there when before we had the glucose testing. You sort of did a chemistry experiment in the bathroom with your urine to see what your blood glucose might have been 4 hours ago. To think of that where we were, and again, thinking I'm not all that old of a guy, to where we are now, it's just miraculous how much type 1 care has improved. To think that continuous glucose monitors are essentially standard of care now, that we have multiple insulin analogs, and that we have insulin pumps that are now talking to those CGMs, and the potential for semi-closed loop systems is almost realized, is just amazing and miraculous. And my grandfather lived into his 80s, even with old school insulin and all those things, because he lived an incredibly regimented life. He was really good at exercising every day and ate his very similar meals, and he was essentially a good patient and did the best you could do with what the technology was. And so I use his experiences with living with type 1 to hopefully motivate my patients and remind them essentially that diabetes is always going to be a terrible disease until we can prevent and reverse it. But if you had to choose a time to living with it, now is not so bad compared to what it used to be like. And now the pace of improvement is just accelerating so nicely that even a year goes by and we discover and improve things better than the last 10 years. So I think the future looks very bright.
I'm always astonished to hear of people who lived well at a time before. You mentioned all these great technological advances, but who lived before home glucose meters. The idea of not being able to check your blood sugar even 2 times a day, or, you have to, as you said, the tabs and, the urine kits, and it's amazing to me. That must have been such a sea change for people like your grandfather. With his diagnosis, does that mean that you can participate in TrialNet? Is he considered enough of a relative?
Right. Well, so I would be a second-degree relative as a grandchild. And now I'm unfortunately above the age limit. You have to be under 21 as a second-degree relative to be screened. But I've been involved in TrialNet, and before that was the diabetes prevention trial that I did get screened back when I was very first starting out in this, because I've been fortunate enough to work with Dr. Desmond Schatz, who's a world-renowned pediatric endocrinologist, was the previous president of the American Diabetes Association. But I've worked with him since I was a teenager, actually. My first experience in really working in type 1 was working in his lab back on the first trial designed to see if we could prevent type 1 using oral insulin. And that was called the Diabetes Prevention Trial Type 1. So back then I did get screened, and fortunately I didn't have antibodies, and I was old enough at that point, even though I was still a kid, to not really need to be rescreened.
That's fascinating. So in high school you knew this was going to be your life. Was that because of your grandfather? What made you want to go into endocrinology?
Yeah, I certainly knew I was pre-med, and I had that experience of seeing my grandfather. But honestly, it was more of a mentoring opportunity than anything else. Dr. Schatz is just such a wonderful person to work with. Really got me passionate and interested about the field. And then I went off. I left. I grew up here in Gainesville, Florida, where the University of Florida is, but I actually went to Duke University for undergraduate school. But when I graduated and it was time to make my decision for medical school, Dr. Schatz was, again, extremely influential, and he really is what convinced me to come back to Gainesville, do medical school here, and then residency in pediatrics. And then along the way, I started participating in diabetes camps, and that was really what did it. The combination of being able to work in a field where I could do some really interesting science, take care of patients long term, and frankly go to diabetes camp, which is just such an amazing experience. Made it very clear to me that I should be a pediatric endocrinologist.
Do you still see patients?
Oh yeah, no, I do. I'm a little bit of a strange breed in that I always have seen myself as a clinician who happens to do research, and so while I don't get to do clinic every day because I have so much research and administrative responsibility now, I would never give that up. And most of the research I do is really patient oriented research. And in fact, I get the pleasure of being able to spend more time with my research patients just because it's not under the same guise as a clinic where you have to see a patient every 40 minutes or hour. So everything I do is really patient based. But I work with an incredible team of scientists, and so I get to work with Mark Atkinson and Todd Brusco and Clive Wasserfall and Clay Matthews and up-and-coming scientists who do a lot of the work in the lab and then bring us these great ideas to try to test in patients. So we have a really unique team here at the University of Florida that allows us to do those things.
I don't know if you can answer this, but I'll ask it anyway. Is it difficult to see patients who are kids? I mean, my son has a great relationship with his endocrinologist. We've been able to see the same one, luckily, from ages 2 to now he's 14. And I wonder, is it difficult to know that you're researching, you're trying to do prevention and, which hopefully even someday cure, but the research is slow. I mean, and we understand why. It's not a criticism, but the research is slow and the patients are growing up. Is it difficult on any kind of emotional level to look at your patients and feel like, gosh, I really want to help these people more, but, the research just isn't as fast as we all would like it to be? Does that make sense?
It's so incredibly frustrating. Frankly, it pisses me off, but it's part of why I get up every morning and come to work, and I'm excited to move things forward. I mean, the pace of research is glacially slow, and I'm not a patient guy. So I've lost my cool more than one time trying to promote what I think is important research so that we can get these things to our patients faster. And that's why I mentioned it. I think like a clinical guy. I just happened to do the research because at the end of the day, that's what pulled me into research. I realized that was what we had to do to get the patients better care. So yeah, I find the process, it's necessary. It's what we have to do. We have to do good science, and that takes time. But sometimes the administrative burdens or the funding lags, those things can just be so mind-numbingly frustrating that really good people, unfortunately, sometimes leave the field. And so I would encourage people not to do that. Of course, we need people to stay passionate about type 1 and do the hard work of the research and the clinical care. But yeah, I have to go to clinic and look people in the eye and say, sorry, I don't have anything that's good enough for you yet. And I emphasize the yet, but that's a hard conversation to have with people day in, day out.
Wow. I'm glad I asked. I wasn't sure that question was going to go anywhere. Sometimes people look at me like I'm crazy when I ask things like that.
No, it's not crazy at all. And it's part of why I'm excited about the anti-thymocyte globulin and ultimately CD3 and all these other things because, we're getting so much closer to the point where I can really say to somebody who's been newly diagnosed, I have something I can actually do for you. And this may no longer be just a research question. I mean, there'll always be research questions because we can improve on things, but I may have a real therapy besides what we've been doing now for close to 100 years, which is just give you insulin. Obviously, we're better at doing that too, but it sure would be nice to do something besides that.
Sure would. You did mention the oral insulin study. My ears perked up on that. Is that complete? What happened with that?
Yeah, it's a good example of this challenge we have between risk and benefit. So for a long time, we've wanted therapies in the type 1 space that would be entirely without risk. And oral insulin, it was one of those. It's a pill that you take by mouth, obviously orally, but doesn't affect your blood glucose. And it's essentially immune tolerizing therapy, or at least that's the idea, to convince the immune system to recognize insulin that gets sort of chewed up in your stomach as being you, and therefore not attack it. And the rationale for those studies were that when you give oral insulin to a particular type of mouse that gets diabetes, it's very effective at preventing the mice from getting diabetes. And so everybody was really excited about it. And so one of the first large-scale multi-center trials designed around the attempt to prevent type 1 was the diabetes prevention trial I mentioned, and that was the precursor to what became TrialNet. And that trial, unfortunately, didn't demonstrate a benefit, although there were some signals that were, suggestive that there might have been benefit in certain subpopulations. And so TrialNet subsequently did, a large trial of oral insulin in that particular population that looked like it might benefit. And sadly, that too failed to demonstrate benefit. And so, I think what that demonstrates is type 1's really hard to fix. And two, that animal models don't always tell us the whole story. In fact, they often tell us the wrong story, but we're stuck using what we got to get some idea of proof of concept. And then lastly, that we are going to likely need to use things that have more potency, that are a little bit more, side effect profile associated to be able to really change the needle on where diabetes is going. That's not to say that oral insulin may not still have some potential for benefit. In fact, we've never tested it when we've given it after something like thymoglobulin or teplizumab or in combination with other immunomodulatory therapies. So there may still be life for oral insulin or other antigen-specific therapies, and there are many others that are sort of in line for testing as well. But that story is, almost 15 years or more of effort, and just again exemplifies how long it takes to find out the real answer. Now, we all want answers quickly, but if we don't do the science the right way, we continue to promote bad ideas and in hearsay, and that's just not how we're going to get to a real therapy that benefits patients.
Mike, we've talked a lot about, the exciting studies and some setbacks and how long things take and the frustration. Are you still jumping out of bed, excited to do this research?
More than ever. I mean, it's a really exciting time to be here because we now have stuff that looks like it actually works. I mean, the feeling in the room in the last decade when we kept going to meetings and reporting negative events was certainly weighing on everybody heavily. And so to be able to come to the American Diabetes Association and report these data nationally and internationally in the last couple of years with the outcomes like thymoglobulin and CD3 really has been a huge boost to everybody's morale. And I think puts us in a really great space because we can continue to argue that people should be getting screened. We should be doing these studies because we are effectively changing the natural history of the disease. So I'm really excited about where we're going, and I just hope we can get there faster.
Wow. Well, Mike, thank you so much for joining me. We'll put all the information about TrialNet in the show notes so that people can learn more and find out how to get screened. But I really appreciate that. Thank you so much for joining me today.
That's been my absolute pleasure.
You're listening to Diabetes Connections with Stacey Sims.
I'll link up more information about TrialNet and about all of these studies at diabetes-connections.com. You can also look at the show notes in any podcast app. There's a little button that says details or something like that. You can just click on that and find out more in the show notes. If you're not already subscribed to our newsletter, I would urge you to do that because we are, over the course of the next year, making these extra episodes available via transcription. It's really what I call transcription plus. We don't speak as we would write. So we've made the transcripts really easy to read. I think they're beautiful. We have cleaned up the language. So, if I say, or, we take that out. But for the most part, it's a direct transcription. But it's easy to read, and I'm really excited about that, and the response has been great. So you're getting that for free. If you sign up for the weekly newsletter, you get the transcription immediately upon signing up, and then you get the next month's, and you pick up from there. Thanks to my editor, John Buchanan from Audio Editing Solutions, for all of his hard work, as always, and thank you for listening. I'm Stacey Sims. I'll see you back here next week.
Diabetes Connections is a production of Stacey Sims Media. All rights reserved, all wrongs avenged.